All right, dear students, and welcome back to this most anticipated session here at sisyaclass. And this is a session especially aimed for the students that are moving from grade 9 to grade 10. Now, in many schools, you have started grade 10 session. Maybe your grade 10 classes have already started. Many of you are in summer vacations and will start after summer vacation. So, whatever be the case, irrespective what is happening, this series is aimed to help you, show you how easy it is to transition from grade 9 to grade 10. And as I'm telling you right now, 85% of the syllabus in grade 10 is related with grade 9 concepts. So it is very essential that we have the basics of grade 9 strong. It's okay if you didn't pay that much attention in grade 9. Just follow this series from start to end, and I will make sure that you will never have a problem. It is going to be a piece of cake for you in grade 10. Now, I just want you to tell you one more thing, that this session is going on in two different languages as well. Now, suppose if you are comfortable in Telugu language, then you can watch the same session in Telugu language, which is taken care by Kaushik sir. And suppose if you want to learn this in Hindi language, you can watch the Hindi session, which is taken care by Shrikesh sir, who is from IIT Gandhinagar. So this is about this complete session, this complete series. I'm going to take care in complete English language. All right. So we are, as I told you, we are moving from 9 to 10th. What are we studying today is from rational basics to irrational proofs, and they're going to be very much basically we are connecting the grade 9 chapter 1, if you remember, number system, to grade 10 chapter 1, that is real numbers. All right, so students, if you just let me just introduce myself. So my name is Rishab. I am maths master teacher here at sisyaclass, both in application and YouTube. You can find me. I have done my education from Indian Institute of Technology, Jodhpur. I have been doing this for quite some time now, more than 5 years, and in my journey, I've mentored 50,000 plus students, and I wish to add more in my more tenure. All right, so let's start, dear students, without further ado. So, as I told you, grade 9, chapter 1, if you remember, what was the grade 9, chapter 1? The grade 9, chapter 1 was number system. Now, what we studied on number system, we studied some topics. I will quickly walk you through all the topics. I will quickly refresh your memory before we start the grade 10 topic. So, we studied what are rational and irrational numbers, if you remember. So, what are rational numbers? I'll just tell you one more time. So, rational numbers are the numbers that can be represented in the form of P by Q, where of course q is not equals to 0. So this is the one condition. So any number which can be represented in the form of p by q is a rational number. I hope it is clear. What are irrational numbers? Irrational numbers are the numbers that cannot be represented in the form of p by q. For example, root 2, root 3, and let's say root 5, root 7. So these are some examples of irrational numbers. For example, for rational numbers, you ask, okay, 1 by 3, maybe 2 by 5. So any rational number, any number that can be represented in form of p by q is rational. Now, let's talk about the decimal expansion as well. So if you can recall, in a ninth grade, we studied that rational numbers have two types of decimal expansion. One is it can be terminating decimal expansion. For example, 2.5. Let's take 7.8. So these are what terminating decimal expansions. And what are another type of decimal expansion? It can be NTR as well. Now, what is NTR? NTR is a short form, stands for non-terminating recurring. For example, let's take 2.33333. So if you can see here, the digit 3 is repeating itself, but this decimal expansion is not terminating. So in short, we call it as NTR. That means non-terminating recurring decimal expansion. If we talk about irrational numbers, what is their decimal expansion? It is NTNR. What is NTNR? Non-terminating, non-recurring. That means it will never terminate, but it will also not have any digit that keeps on recurring itself, repeating itself. For example, let's take 3.1457. I hope you know what I'm trying to say here. All right, no digit will repeat here. Next, we learn to represent irrational numbers and rational numbers on number line. Rational numbers we have been doing for and before grade 9 also, but we learned how to represent irrational numbers on number line. I hope you remember this. I'll just quickly tell you what is this called? Square root spiral. So what I will do, I will take axis. This is 1. I will draw 1 here, and this is by applying Pythagoras theorem. I will write the square root of 1 square plus 1 square, that is square root of 2. So this is also we have studied in previous grades. Next, we studied how to convert fractions. So if we have any decimal expansion, be it terminating or non-terminating recurring, of course we cannot convert NTNR into fraction form because these are irrational numbers. So if we have learned how to convert them, there were some amazing tricks. I'll suggest you, if you have any doubts regarding this, go back. You can check our grade 9 channel as well. You will find many videos there. Next, we learned operation and rationalization, in which one particular identity was a minus b times a plus b. This you should know because this identity is going to be used, and not in this chapter alone, but everywhere in this whole 10th grade. So in moving to grade 10, now in grade 10, we are going to again, first, I'll just quickly walk you through rational and irrational numbers. I hope you know this. We have discussed in some depth. Next, advanced HCF and LCM. Now, HCF and LCM we have learned on which grade? In grade 6, we have learned HCF and LCM. We are again revisiting that in grade 10, but what is the difference that is going to be? The difference is that we are going to deal it at a very advanced level. We are also going to discuss relationship between HCF and LCM, both for two numbers, for three numbers. Three numbers is not that important for the exam perspective, but again, since we are not targeting for exams, this is just a transition. I'm going to help you in transition, so we are going to discuss that also, and we are also going to prove how any number can be proved as irrational. All right, amazing. Let's start. So first, well, I'll start with a very real life example. So suppose we have two strips, as you can see in front of your screen. There are two strips. The length of the first strip is 36 centimeter, and the length of the second strip is 24 centimeters. Now we have to find what is the largest length of equal strips. See, the thing is, you have to take care of two things here. The largest length we have to find on equal strips that can be cut from these two strips. Now, this the first way is like what we can do, we can place 24 centimeters strip on 36 centimeter and then cut the rest of part. It is working here. We will get 12 centimeter, but it is not case. As you remember in grade 6, we have found how to find HCF using subtraction method. I hope everyone knows this. So this is one HCF subtraction method, but in this case, what we are going to find, if we try to find this, you will get strips of 12 centimeter, 12 centimeter, 12 centimeter, 12 centimeter, 12 centimeter. And dear student, this is the largest length. Of course, if you have 2 centimeter, that can also be equal and can be cut out from the strip, but we have to find the largest length of equal strips that can be cut out from these two strips. So in this case, the length of the strip is 12 centimeter. And what is this called? So dear students, this is called as what we are finding. We are finding the largest number that can divide both 36 and 24. That's what we have to do, right? And in this case, that is 12. And this is known as HCF, or highest common factor, or in some books, it is also called as GCD, that is greatest common divisor. I hope it is clear up till now. So this is one real life application which I have tried to show you. Let's move forward. So in today's class, what we are going to discuss HCF and LCM in great detail. The formula will change. The concept will remain same. The concept of whatever we learned in grade 6, grade 8, the concept will remain same. But in this, we are going to change the formula, tweak the formula a little bit. And now, of course, you're big kids right now. You're in grade 10. So you should be dealing with like big kids, right? And we are also going to discuss irrational numbers at length, like how to prove irrational numbers. What are irrational numbers? What are irrational numbers? You already know this. How to prove irrational numbers. It's going to be a really good thing. All right, so let's start. But before we get into H7 and L7 all thing, I just want to tell you what is fundamental theorem of arithmetic. Now, I just wanted to take one moment here. This fundamental of theorem of arithmetic you have been studying in 6th grade itself. We teach it in Sysya app. We teach fundamental of arithmetic to grade 6th child, or maybe grade 4 child also. The thing is, just read the statement. The statement says every composite number which has more than two factors can be expressed at the product of only prime numbers, and this representation is unique. The thing is, dear students, what are composite numbers? First of all, if you are not able to recall, composite numbers are the numbers that are having more than two factors. That is, what are prime numbers? The numbers that have only two factors, the number itself and one. But composite numbers are the numbers which have more than two factors. That is, two factors will be there. The number itself and one will be there, but another, for example, 6. What are the factors of 6? 2, 3, and 1. So 6 is a composite number. Now, the thing is, if we take prime numbers, we can get infinite composite numbers. But what fundamental theorem of arithmetic says that every composite number, be it any number in the world, can be expressed as product of only prime numbers, and this representation is unique apart from the order which it occurs. So this is what fundamental theorem of arithmetic is. For example, if I write 24, now 24 can be written as what? 2 times 2 times 2 times 3. That is 2 cube times 3, right? Similarly, 100 can be written as 2 times 2 times 5 times 5. That is 2 square times 5 square. Now see, these numbers 2, 3, here also 5 are all prime numbers, right or not? Yes. So what does it say? A product of only prime numbers, and this representation is unique, my dear students, unique apart from the order. What do you mean by apart from the order it occurs? That means I can also write this as 3 times 2 cube. Yes. This is straightforward, right? So apart from the order, this representation is unique, and this statement which I'm telling you, the statement that this representation is unique is the most important for the rest of our class. So make sure you note it down. You can pause the video, note down this thing. Again, very easy. Now, no need to like memorize it or something. It is coming naturally to us. All right. So one application for this is one type of question that you can get is, can 4 raised to power n and end in 0? No distance. First of all, 4 raised to power n is there, right? So 4 raised to power n, how can I represent this? I can write 4 as 2 square. So this is nothing but 2 square times n. Then applying the law of exponent, this 2 and n will be multiplied. So this becomes 2 raised to power 2n. That, what does that mean? It is 2 into 2 into 2, so on, 2n times. That's what it says. No. Now, distance, tell me, if a number has to end with 0, it should have both 2 and 5. Yes or no? Okay, try to visualize it like this. 10. 10 is what? 2 times 5. So 5 is there. If I say, let's say 20, what is it? 2 times 2 times 5. So if you can see, take any number and try to prime factorize it, you will always see the number 5 here. But tell me, is the number 5 here? No. But the thing is, based on this factorization is unique. Why? Because fundamental theorem of arithmetic says, be it any composite number. So this is a composite number. It can be represented as a product of only primes. The only primes are there, and this factorization is unique. So I can for sure say that in this factorization, at any part, we will not get the number 5. That means 4 raised to power n can never, ever, ever end in 0. I hope it is making sense. So suppose there can be another question, let's say 6 raised to power n. Can 6 raised to power n end in 0? Of course not. Again, same logic, because 6 raised to power n is what? 2 raised to power n times 3 raised to power n. Are we seeing the digit 5 here? No. Then can it end in 0? Never. I hope it is making sense to you, everyone, right now. If you have any questions, dear students, I know you can just type in comment box. I will be checking. I will make sure that I will check all the comments and I will answer all your doubts. If you have any feedback for me up till now, you can always tell me. I can incorporate that feedback, because anything, this is for your benefit only, dear students. We have started this series from grade 9 to grade 10 students. Now, if you can see, okay, let's go to another question. Then I'll talk about pilot course in detail. So this is the statement that you have to write in the exam, that for 4 raised to power n to end in 0, its prime factorization should have at least 1 to make it 5. It has only 2. So no, it cannot end with 0. Clear? Great. All right, let's move to HCF, or we call it as GCD in some books. Anything in NCRT, we call it HCF. It is short form for highest common factor. We start in the start itself. You remember with the strip question, we had two strips, 36 centimeter, 24 centimeter. We had to find the highest or the maximum length of the equal strips that can be cut from them, right? Now, in this case, HCF of 16 and 12. Suppose HCF of 16 and 12, 4 is the highest number that can divide both 16 and 12, right? You remember how to find the HCF? Okay, but in 10th grade, we have a different formula. Let me introduce the formula. But before that, what is LCM? LCM stands for lowest common multiple. LCM of, suppose, let's say same number, 16 and 12. And if you have to find the LCM, LCM is becomes 48. That is 48 is the lowest number that can be divided by both 16 and 12. See, highest common factor and lowest common multiple. Now, if we talk about grade 10 formulas, now the grade 10 formulas are like this. HCF is product of the smallest power of each common prime factor in the numbers, and LCM is the product of greatest power of each prime factors in the number. See, I'm telling you, this is going to be a bit tricky, but I tell you one easy trick. See, HCF, H stands for what? Highest. So whenever we have HCF, it will do opposite. See, this is what you have to take care. HCF is highest common factor, right? So the formula will be given by product of the smallest power of each common prime factor. Now this is a 5-star formula. You have to write, as I told you, if you're attending my class for the first time, what I tell you as a 5-star formula, that means you have to write that formula in a page, in a blank page, place it on your study table. You can stick it in your wall if your like parents are okay with that. So stick it on, because these are some. In grade 10, we have around 50 plus 5-star formulas, and if you can learn that 5-star formulas, I'm 100% sure no one can stop you to get more than 95 plus in the mathematics, if you're talking about maths only. So HCF is what? Product of smallest power of each common prime factor. First thing, we have to consider each common prime factor, and we have to see the smallest power. Okay. LCM is what? Product of greatest power. See, again, this is least, so this is greatest. Least means greatest. Power of each prime factor in this. See, in this each common prime factor in this, we have to reach each prime factor. All the prime factors we have to consider. And it's okay if you are able to understand, let's say 50%. What I want you to do, just pause this video, write this formula down in your notebook as it is 5 star. Draw 5 stars. Yes, I want you to literally draw the 5 stars because these are 5-star formulas. Let's see with the help of an example. Okay, let's consider the number 48 and 60. We found the HCF 12. But let's see. So first of all, what you have to do, you have to prime factorize 48 and 60. I hope you know how to do prime factorization. I'll just quickly refresh your memory one more time. How will we do prime factorization? I will write 48 here, then 2, it will go 24 times. 2, it will go 12 times. 2, it will go 6 times. 2, it will go 3 times. And 3, it will go 1 time. So how many 2's we are getting? 1, 2, 3, 4. That is 2 raised to power 4 times 3. Similarly, you can prime factorize 60 also. I believe, I'm sure you will be able to do that. That will be 2 times 2 times 3 times 5. Or in short, we can write 2 squared times 3 times 5. Now, how to apply the formula? See, highest common factor. We have to consider, first of all, each common prime factor. So what is common between 2, 3, 2, 3, 5? Of course, 2 and 3. And we have to see the smallest power. So for the smallest power of 2, it's what? It's 2 square. And the smallest power of 3 is 1. Both the cases, it is 1 only. So 4 times 3, it will become 12. I hope it is making sense. Yes or no? Great. Amazing. Let's move to LCM. For LCM, what we have to do, see, prime factorization is done. 2 raised to power 4 times 3, 2 square times 3 times 5. But for LCM, we have to again consider prime factors, but we have to consider every prime factor that you can see. I can say 2, 3, 2, 3, 5. I read 2, 3, 5. Next, since it is LCM least, we have to consider the greatest power. The greatest power here is what? The greatest power of 2 is what? 4. So I write 2 raised to power 4 times 3 times 5. Now 2 raised to power 4 is what? 8. 2 raised to power 4 is nothing but 2 into 2 into 2 into 2. You can easily find that 4 times 4, that is 16, and 16, then I will multiply 16, I will multiply with 3 multiplied by 5. I will get the LCM as 240. I know there are multiple ways to solve this. You can do this using the prime factorization method. You can find that, but this is the easiest method. And in grade 10, this is expected from you that you solve it using this methods. I hope it is clear. Great. So we have found the thing, HCF is 12 and LCM is 240. But dear students, observe one thing here. Observe HCF of 48 and 60 when I'm multiplying with LCM of 48 and 60. So HCF is what? 2 squared times 3. Okay. What is LCM? 2 raised to power 4 times 3 times 5. Okay. So if I'm multiplying this, this becomes 2 raised to power 4 times 3 times 2 squared times 3 times 5. Right? We're getting it. So if you are able to see, this is nothing but 48 multiplied by 60. Yes or no? Aren't these two the original numbers? The HCF of 48 and 60 multiplied by LCM of 48 and 60 is equals to 48 multiplied by 60. So what does it mean? This means we have a relation between us that if we have only two numbers, first of all, this is only valid for two numbers. The relation says HCF into LCM is equals to product. That means I will write it here one more time. HCF of A and B multiplied by LCM of A and B is equals to the product of A and B. This is another 5-star formula. So second 5-star formula for our this chapter. So what was the first formula? The HCF and LCM, how to find that. And second 5-star formula is, of course, this is very easy formula to remember. HCF into LCM is equals to product of the numbers. Clear? I hope it is clear, right? All right. Okay, let's do one example. Now, this examples I'm just going to do for your sake. It is just solve along with me, or you can pause the video right now, solve it at your own, and just cross-verify it. So we have to find the HCF of 96 and 404 by prime factorization method, and also we have to find LCM. Now 96, first of all, I will prime factorize. How will I prime factorize 96? I will write it here 96. Then 2, it will become 48. Then again 2, it will become 24. Then again 2, it will become 12. Again 2, it will become 6. Again 2, it will become 3. So what it is, 1, 2, 3, 4, 5. So I'm getting 2 raised to power 5 times 3. Right. Similarly, I can prime factorize 404 also. How will I prime factorize 404? Okay, let me do it here. So 404, I will first divide by 2. First prime number is 2. Always you will divide with 2. 202. Then I will have 2. Then 101. Then 101. So what I can write, 101 is a prime number. I cannot factorize it further. So it will become 2 square times 1, 0, 1. So first step first, is it clear? Yes or no? HCF, first of all, before finding HCF or LCM, we will do prime factorization, and I will write it in this exponent form. Okay. Now, how do I find HCF? Now, if you remember, if whenever we have to find HCF, we have to consider only and only the common prime factors. So, what is the common between 2, 3, 2, 2, 101? I hope everyone knows that this is 2. Right. Now, see, one more thing. We have to consider, since it's an H that is highest, we have to find the lowest power of each common prime factor. That is 2. So, HCF is 4. Now, we can find LCM. LCM, you can find two ways. I'll tell you. First of all, if we have to find LCM, what I will do, I will consider all the factors, that is 2, 3, and 101, but I have to consider the highest powers. So what is the highest power of 2? 5. Highest power of 3, 1, and 101 also 1. Now it is what, 2 raised to a 5, 2 raised to a 5. I hope everyone knows how to calculate. See, to always, this you should know. Now 2 raised to a 4 is what? 16. 16 times 2, 32. So 2 raised to a 5 is 32 times 3 times 101. Now, 32 times 3 is what? 96 times 101. Now, don't do, and I am, dear students, I'm telling you, see, this is very important what I'm telling you right now. You are in grade 10 right now. You will not do 101 times 96 like this. No, no, no. These are for small kids. This is what grade 4 kid will do. We will not solve it like this. 96 times 101, you will just get 9696. How it happened, dear students? That's why I'm telling you, it is very essential that you know these tricks by now, because you're in grade 10. If we have any two-digit number and I'm multiplying with 101, I will get same number written twice. That is, I will get AB, AB. Suppose if it is three-digit number ABC and I'm multiplying with 1001, what I will get? ABC, ABC. These are very important tips and tricks which I've been telling you. And again, dear students, in here at CISA class, that is how we are different from everyone. What I'm going to teach you, or what every teacher is going to teach you at CISA class, first of all, we are a team of top IIT and NIT expert. If you can see the other series that is going on, Shrikesh sir, he's from IIT Gandhinagar, Kaushik sir, he's an NIT teacher. So that's why, dear students, I'm telling you, these tricks are very, very important. See, what does it do? It is not for just show off purposes. See, as I told you, in this time, at least we save 1 minute, yes or no? Now, this 1 minute in 10th grade, if you want to get the 100% results, what you have to do, you have to learn time management. It is, you have to spend some greater time in some other question. You can spend some time in other question and you can save time here. Again, dear students, as I tell you, you can see a QR code, or you are able to see phone number, or you can check the description box. We are running a pilot course program in our Sisya class app. Now, in this pilot course program, you can enroll right now, and using the link, you can get this for just rupees 29 for one entire week, in which you will be getting subjects like maths, physics, chemistry, biology, coding, and robotics. There are going to be everyday live classes. This is just a trial course, and one big announcement, that if you are enrolling in our pilot course program, you will also get the chance to write one scholarship test. Now, if you are able to do good in scholarship test, you can get some really cool, really good amount of scholarship for you, because we would like to reward our brightest minds that are studying with us. So again, just and complete your enrollment right now, and start your journey with us. All right. So whenever we have three numbers, if you have three numbers and we have to find HCF and LCM using prime factorization method. So again, I will do what? 6. I can write 2 times 3, no brainer. 72. Now you can prime factorize this. Okay, I will do it one more time. 72, what will it become? 2, then 36, then 2, then 18, then 2, you'll get 9. So it will become 2 cube times 3 cube, 3 square. I hope everyone can do this. Similarly, if I try to factorize 120, I'm doing it here. I will write 2, then 16, then 2, then 30, then 2, then 15. 15, everyone knows it is 3 times 5. So it will become what? 2 cube times 3 times 5. Now let's find HCF. HCF is no brainer. Yes. What I will do, I will take the common prime factors only. What are common prime factors? 2 and 3. And that too, I will only use their highest. That means I have to use the lowest power. So lowest power is 1 only. So what is HCF? HCF is 6. Right. Now, how to find LCM? In LCM, what I will do, I will list all the common prime factors, not common, everything I will use. 2 into 3 into 5. And I will take, since it lowest L is there, that means I will take the highest powers. So what is the highest power of 2? 2 cube. What is the highest power of 3? 3 square. And 5 is nothing but 5. This is 8 times 9 times 5. I hope everyone can do this. This is 8 times 4. 8 times 5 is 40. 40 times 9, 360. Okay. Yeah, correct. So I hope this is 2 cube, 3 square times 5. Yes. So I hope it is clear to everyone now. Yes or no? All right. Okay, one more question. We are given that HCF of 306, and there are two numbers, 306 and 657. Their HCF is given as 9. We have to find the LCM of 306 and 657. Remember, what is the relation I told you? If we have HCF of two numbers, if I multiply with the LCM of the two numbers, it is going to be the product of the two numbers. So what are the two numbers? Numbers are 306 and 657, right? HCF is given to us as 9. This is 9 times LCM is equals to 306 times 657. Now what I'm going to do, I'm going to take 9, I'm going to divide it here. What I will get, 306 times 657 over 9. I hope it is pretty easy, clear. Yes. Now, what I will do, I will just solve this and just solve it on your own. Tell me the answer in the comment box. I will tell you whether your answer is correct or not. Just pretty straightforward, just cancellation, and you will get the LCM. So I hope you know how to find HCF. What is the relation between HCF and LCM? HCF times LCM is equals to the product of the two numbers. Great. Awesome. Okay. So this is done. Let's do one more question. This is a word problem. Now, whenever you have word problem, dear students, I'll tell you one very easy trick how to solve one problem. So let's read the problem first. There is a circular path around a sports field. Okay. So see, this is how you should read the question. There is a circular path. Okay. I have drawn a circular path like this. Sonia takes 18 minutes to drive one round of the field. That means if Sonia is here, if she's starting from this point, going, and coming back, she takes how much time? 18 minutes. While Ravi takes 12 minutes to do the same. That means if we have Ravi also starting at this point and he goes and goes on going, comes back, he's going to take how much time? He just take 12 minutes. So obviously Ravi is faster, but we are not dealing with that. Now the question is, suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Now, in this question, we have to find, we have 18 minutes and 12 minutes. Obviously, the question is saying that we have to find LCM. Find LCM. How? Because we have to find after how many minutes. That means if, let's say one round, Sonia is taking 80 minutes. For two rounds, she will take 36 minutes. For three rounds, she will take 54 minutes. So similarly, Ravi, for first round, he will take 12 minutes. Then he will take 24 minutes. And then he will take 36 minutes. So after how many times? Actually, if you know, I told you the answer. So basically, we have to find the multiples and we have to see the least common multiple. That is the first multiple of 18 and 12. Now, how to find 18 and 12 LCM? I hope everyone knows this. This is 2 times 9, that is 3 square. And I can write 12 as 2 square times 3. Right. Now, how to find the LCM? What I will do, I will take all the factors, that is 2 and 3, and I will take the highest power, that is 2 square times 3 square. Now, 2 square is 4, 3 square is 9. So they will meet again after 36 minutes. If you remember, I have in the explanation itself, I have told you the answer. 18, one round, 18, second round, 36. So Sonia will take two rounds. Ravi, first round, 12 minutes, second round, 24 minutes, third round, 36 minutes. So at the 36th minute, they will again cross their path one more time. What about next? So you're getting the idea, right? I hope it is clear. Okay. Let's move on to irrational numbers now. So irrational numbers, I have already covered the definitions. So irrational numbers are those numbers that cannot be expressed in the form of P by Q. Of course, Q is not equal to 0. That is done. So what are the examples? Root 2, root 3, root 5, pi. Dear students, here's a question. What is the value of pi? 3.14 or 22 by 7? Now you must be thinking, what are you asking, sir? Both are the value. No, no, no. Both are not the value. These are not values. These are approximate values of pi. Pi is an irrational number. That means its decimal expansion will be NTNR. Can it have a terminated decimal expansion? No. Can it be represented in the form of P by Q? It cannot, because that is what definition of irrational number is. It cannot be represented in the form of P by Q, so it's not 22 by 7. These two are actually the approximate values of pi, which we use to just ease up our calculations. Clear? All right, let's move forward. So we will be extending the fundamental theorem of arithmetic. There is a proof also, but the proof is not required, but I will still show you the proof. You can write it down, pause the video, take screenshots. It will be very helpful. But what does the fundamental theorem of arithmetic? We will extend that theorem. What does it say? If P is a prime number, if P divides A square, then P divides A, where A is a positive integer. So what does it say? Suppose if we take, let's say, number 36, and let me take a prime number, let's say 3. Okay. Now, does 36 divides 3, does 3 divide 36? Of course, yes. So according to this theorem, 3 will also divide 6 as well. Now, you may seem, sir, this is very obvious, but that is what? No, it is obvious to you now, but the theorem says let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. This is the third 5-star concept, and I want you to note this right now, because this concept is really important when we are going to prove irrational numbers. But for this the proof is not required. But what we will do, by fundamental theorem of arithmetic, we can write A as the product of primes. Next, we will do squaring both sides, so A square will become this thing, P1 times P2 times Pn. I will write it twice, so A square will become P1 square, P2 square, and so on till Pn square. Next, given P divides A square from fundamental of theorem of arithmetic, P is one of the prime factors of A square. Why? Because P is dividing A square, right? So using the uniqueness part of the fundamental of theorem of arithmetic, the only possible prime factors of A square are P1, P2, and Pn. So P has to be one of them. Since A is P1, P2, Pn, P divides A. So dear sir, again, the proof is not important for you, but still I have given you. You can take a moment, write it down, and if you have any confusion in the proof, you can tell me in the comment box below. I will make sure to answer your comment, answer your doubt there also. But again, what is the application of this? This application we are going to use to prove irrationality of numbers. Say with me one more time. If P is a prime number, if P divides A square, then P divides A as well. Okay. Now, using this, we can prove that root 2 is irrational. Now, this is very critical proof, and I'll tell you, every teacher will tell you the same. This proof is very important. It has a fixed pattern of whenever you are doing the proofs. So for this, we will use that one method that is called as method of contradiction. Now, what does it say, method of contradiction? Here we are first going to make an assumption, which we know it is not true, but we'll assume that it is true. Then we will solve, and come at a conclusion that contradicts our assumption. So again, what is the assumption? So we have to prove root 2 is irrational. What I will do, I will assume root 2 as rational. Now, if I assumed root 2 as rational, that means I can represent root 2 in the form of P by Q, where P and Q are co-primes. This is one important condition which you have to remember. P and Q are co-primes. What are co-prime numbers? The co-prime numbers are the numbers that have no common factor. For example, 1 and 3. They are in the simplest form. It cannot be simplified further. So if root 2 is P by Q, where P and Q are co-primes, then what I will do, I will cross multiply both the sides. I will get root 2 times Q is equals to P. Next, I will square the equation both the sides. I will get 2Q square is equals to P square. From this, dear students, what I am able to get, I am able to get that 2 divides P square. 2 divides P square. Now, using the theorem that we have just now studied, 2 is a prime number, yes or no? And 2 is dividing P square. That means 2 will divide P also. Yes or no? That's what, no? 2 will divide P as well. So what I can write? I can write P is equals to 2K for some constant K. I don't know. K is a constant. I can write it P as 2K. Up till now, clear what I did. I assumed that root 2 can be represented as a in the form of P by Q, where P and Q are co-primes. That means they don't have any common factor. So what I have, root 2 P, Q is equals to P. I squared both the sides. I got 2 P, Q square equals to P square. Now 2 is dividing P square. That means 2 will divide P as well. That means P can be written as 2K, where K is a constant. Now what I will do, I will use this second equation and I will place it in first equation. If I'm doing it, what I will get 2Q square is equals to 2K whole square. Yes or no? Now again, if I simplify, I will get 2Q square is equals to 4K square. 2 and 2 will get 2 and 4 will get cancelled. What I'll get, 2 square is equals to 2K square. Again, same thing. Q square is 2K square. That means 2 divides Q square. Yes or no? 2 divides Q square. That means 2 divides q as well. But what is this? In the previous slide, we have written 2 divides P, and here we are writing 2 divides Q. But what is the assumption we have made? Assumption we had made was that P and Q are co-primes. That means they have no common factor. But by result of this, we have found that there is a common factor 2. So what does it mean? That means our assumption was wrong, and this contradicts our assumption. That's why root 2 is irrational. It is a it is just one algorithm you have to remember, and it is very easy once you remember this. All right. Let's move to one more type of question that you can get. Prove that 5 minus root 3 is irrational given that root 3 is irrational. So what is given to us? That one number root 3 is already, this is irrational, sorry. This is irrational. So root 3 is already given as irrational. We have to prove that 5 minus root 3 is also irrational. Now, how will I do? Again, the same method of contradiction. What I will write? 5 minus root 3. I will this time, let's write a by b. Where a and b are co-primes, and of course b is not equal to 0. I will do the I will take a by b here. I will get 5 minus a by b is equals to root 3. So what I'm going to get 5b minus a over b is equals to root 3. Now tell me, dear students, a and b, first of all, if I'm writing a and b are integers, now tell me, if b is an integer, 5b will also be integer. Take any example, take minus 2. Minus 2 is an integer, 5 minus 2, or 5 multiplied by minus 2 is minus 10, also integer. A, so integer, 5b, this is an integer, a is also integer, integer minus integer, every case it will get integer, and b is nothing but integer. But so in LHS, we are having an integer by integer, that is for sure it is a rational number. But in RHS, we are having root 3, which is given in the question as irrational. This contradicts our assumption one more time. That means 5 minus root 3 is irrational. This type of questions are most frequently asked. The earlier type you will know, perhaps not get, but this type of questions are very much asked by CBSE in the board examination these days. All right, but still it's very important, be it for your midterm examination, pre-boards or final boards, all these concepts you should know. I hope it is clear. You can also prove root 5 as irrational, root 7 as irrational, or let's say root 3 as irrational. I hope you can just follow the same thing, same algorithm, and you can prove anything now. So this is clear. All right. Next, one bonus thing, one bonus topic. This is not in your syllabus per se, but it is very important. See, again, we are right now focusing on the foundation of the topics. This is the starting time. Your board exam is not due for another 10-11 months, but it is very important how to do this. For 3 numbers, if we have the LCM of 3 numbers, PQR will be given by the product of the 3 numbers multiplied by the HCF of the 3 numbers whole divided by HCF of 2 numbers taken at types. That is HCF of P and Q, HCF of Q and R, and HCF of R and P. HCF, on the other hand, just everything will replace, that is PQR multiplied by LCM of P, Q, and R divided by LCM of 2 numbers taken at time. That is LCM of P and Q, LCM of Q and R, and LCM of R and P. I hope it is making sense. Yes. Again, this is not in syllabus, but again, since you are good kids and this is just the start, make sure you write it down in your notebook. Just for the for your practice, there's a question that is HCF of 12, 14, and 16 is 2. We have to find the LCM. Just apply the formula. Tell me the answer in the comment box below. I will tell you whether the answer is correct or not. And that's it, dear students. So this is the end. So thank you, dear students, for tuning in with us in this series. Do let us know what are you thinking about this series? What are the other expectations? What do you want more from our side? I'm sure we will be able to provide that. But again, once again, thank you for being such a wonderful audience. If you have any doubts, you can always ask in the comment box below. And do check out our pilot course program. You can see the QR code in front of your screen. You can also see the number being presented, and of course you can always check the description box. Do enroll in our pilot course program. It will only cost rupees 29. In rupees 29 you're going to get 6 classes. You can see per class for 1 hour you just have to pay 5 rupees, and trust me, you don't take my word for it. Just take it give it a try. I'm sure you will never be disappointed. This is a very good initiative. All right, so I'll see you there in the next video. The next video is going to be about polynomials. And again, if you are interested in Hindi or pure Telugu or pure Hindi classes, you can check Shrikesh sir class, or you can check Kaushik sir class, who is delivering in Telugu. All right, so that's it from my side, dear students. Thank you so much for joining once again. Bye bye. Take care and keep studying.